Hello, my dear Butcho, and welcome back. I know, exams are so close and the tension is real. But please don't worry. Today, we're going to revise a chapter that, believe it or not, you already use every single day. Proportional reasoning. We're going to make it super simple, and by the end of this, you'll be solving these problems like a total champion.
Okay, let me ask you something. Has this ever happened to you? You click a fantastic photo, you want to post it on Instagram, but when you try to change the size, suddenly your face looks all long or wide and just weird. So frustrating, isn't it? Well, guess what? The reason and the solution are right here in your math textbook.
Just look at this. On one side, we have this perfect picture of a tiger. Looks great, nah? But on the other side, it's the same tiger, but it looks all stretched out and wrong. Why? Why does one look so good and the other one, not so much? The answer, my dears, is a simple secret code from math.
And that secret is all about keeping things in proportion. To figure this out, we're going to become detectives and look for clues in these tiger pictures, which I'm sure you'll recognize right from your textbook.
So, first up is image A. Let's call this our perfect original picture. Everything looks right, everything is balanced. This is our gold standard, okay? Let's remember this one.
Now, look at these two. One is much smaller and the other is much larger than our original. But notice something? They still look perfect. The tiger isn't stretched, he isn't squashed, he looks just right. Even though the size changed, the feel is the same, and this is a very big clue for us.
Okay, now for the really interesting part. Let's look at the numbers behind the pictures. The first picture was 60 millimeters wide and 40 high. The small one is 30 by 20. And the big one is 90 by 60. Just take a second and look at those numbers. Do you see some kind of a pattern? Some connection between the width and the height?
And here it is. This is the secret. To make the picture smaller, they divided the width by 2, and they also divided the height by 2. To make it bigger, they multiplied the width by 1.5 and did the exact same thing to the height. See? When you change the width and the height by the same number, the picture stays perfect. That's the whole idea.
Now in maths, this special relationship, this connection between two numbers, like width and height, has a special name. We call it a ratio. And if you can understand ratios, you've pretty much cracked the code for this entire chapter.
So what even is a ratio? Don't let it scare you. It's just a simple way to compare two numbers. We just put two dots, a colon, between them. So we say it as A is to B. It's just a comparison, that's all.
So let's go back to our perfect tiger. For image A, the ratio of its width to its height is 60 is to 40. That's it. It just means for every 60 units of width, you have 40 units of height. See? Simple.
But this brings up a good question. The numbers 60 and 40 are different from 90 and 60. So how can we prove that they represent the exact same perfect tiger shape? Is there an easy way to check? Yes, there is. We just simplify the ratio. It's exactly like simplifying a fraction. First, you find the biggest number that can divide both parts, the HCF. For 60 and 40, that number is 20. Then, you just divide both numbers by the HCF. So, 60 divided by 20 is 3, and 40 divided by 20 is 2. So the simplest form of our ratio is 3:2.
And here comes the magic. If you simplify the ratios for all the perfect-looking pictures, guess what? They all become 3:2, every single one. But the distorted, weird-looking pictures, their ratio simplified as something totally different. This is the proof. The simplified ratio is what tells us if the picture will look right.
So, this is the most important sentence of this chapter. I want you to remember this for your exam. If two things are proportional, it just means that when you simplify their ratios, you get the exact same answer. That is the entire secret. Really, that's it.
All right, now that we know the secret code, let's actually use it to solve some problems. This is how you're going to take this knowledge and turn it into full marks on your exam paper. Okay, first problem. Let's imagine Kasang is making some lovely nimbu pani. Her recipe for 6 glasses is 10 spoons of sugar. Now her friends have come over and she needs to make 18 glasses. To make sure it tastes just as yummy, how much sugar does she need?
Well, for the taste to be the same, the ratio of glasses to sugar must stay the same. It must be proportional. So we set it up like this. 6 glasses is to 10 spoons, as 18 glasses is to some unknown amount of sugar. That's what we need to figure out.
And solving this is so easy. Just ask yourself a simple question. How did we get from 6 glasses to 18 glasses? Well, we multiplied by 3. So, because it has to be proportional, we do the exact same thing to the other side. We take the 10 spoons of sugar and we multiply that by 3 too. And we get 30 spoons. Simple as that.
You know, what's really amazing is that this method is thousands of years old. The great Indian mathematician Aryabhata had a name for it, the rule of 3. It's the same logic. So when you're solving these problems, you're actually using ancient Indian wisdom. How cool is that?
Okay, time for the next type of question you will definitely see in your exams. It's about sharing something in a ratio. Let's say Prashanti invests 75,000 rupees in a business, and her partner Bhuvan invests 25,000 rupees. Together they make a profit of 4,000 rupees. How should they split that profit fairly?
There is a simple 4-step recipe for this. First, find the ratio of what they invested. 75,000 to 25,000 simplifies nicely to 3 to 1. Second, add those ratio parts together. 3 plus 1 gives us 4 total parts. Third, find out how much one part is worth. The total profit is 4,000 rupees, divided by 4 parts, that's 1,000 rupees for each part. And finally, step 4, give them their shares. Prashanti gets 3 parts, so that's 3,000 rupees. Bhuvan gets 1 part, so that's 1,000 rupees. Fair and simple.
And looking at it on a chart makes it so clear. Prashanti put in more of the money, so she gets the bigger share of the profit. Bhuvan put in less, so he gets the smaller share. It's totally fair because it's proportional to their investment.
All right, my brilliant students, we are at the very end. Before I give you a final challenge, I want you to say this golden rule with me. Proportional just means the simplified ratio stays the same. If you remember only this one thing, you can solve any problem from this chapter.
So, here it is, your final challenge, and it's a tasty one. To make yummy, soft idlis, the recipe says the ratio of rice to urad dal should be 2 to 1. If you need to make a total of 6 cups of the mixture, how many cups of rice and how many cups of dal will you need? You can use that sharing method we just learned. Go on, pause the video and try it out. I am 100% sure you will get it right. You are all superstars. Best of luck with your exams.